These are very recent projections from an organization called the US EPA. Please remember that, because it won't exist for very much longer, which is rather sad, because it was a very good source of hard science and reliable projections. And this is their most recent and perhaps their last set of projections for greenhouse gas emissions. And this is between where we are now. We're about just up the left end of the scale there, going up to the end of the century. And the thing that really jumps out at you is the extremely large uncertainty range. The bottom scenario, which is in red, the lowest emissions pathway, this would only happen if we have a combination of really quite aggressive actions by governments, significant and fairly rapid technological substitution, and that means that if we can do all of the above, we would end up with greenhouse gas emissions by the end of the century being roughly where they are now, or perhaps a little higher. But the high-end scenario is about 3.5 times higher than that. That's an enormous temperature variation. The difference, of course, is because the reason why we're talking about such uncertainty is it depends. It depends on decisions we're going to make in the interim. It depends on policy decisions. It depends on economic growth rates. It depends on the extent to which those growth rates are correlated, as they have been in the past, with increased demand for energy. And it depends on technological substitution and the rates of technological substitution. And none of these it can be known with any level of certainty, which is why we've got such a large range there. If we end up with the high end, obviously, we're looking at some fairly disastrous consequences. Let's just map that on now to the associated impacts in terms of changing global climate. And you can see there's a similar range. But it is now, I think, inconceivable that we're going to end up with a temperature round about world average surface temperature where it is now. It's probably going to be at least 1.5 degrees warmer by the time we get to the end of the century, because there is a very long delay built into climate change. It takes a long time for the oceans to absorb heat, and they will be somewhat warmer. Even if we can achieve the low-end scenario, the oceans will still be warmer several hundred years from now than they are now, and that heat will be gradually released back into the atmosphere. So it is now extremely unlikely that by the time we get to 2100, the surface temperature is going to be anything less than 1.5 degrees warmer than it is now. And we're already almost 1 degree warmer above where we would have been had we not had gone through a very energy-intensive period of growth. The high-end scenario is a 4, and some scenarios even 7 degree rise in average surface temperature. If we get even close to that, we're looking at a range of really quite disastrous consequences, because the combination of temperature increase, sea level rise, and critical water shortages will make some parts of the world's surface uninhabitable, which means that we're really looking at patterns of forced migration with all of the associated risk for conflicts that will go with that. I know that we in the islands like to talk about the impacts on the islands, but it's worth remembering that something like 99% of total global impact will affect mainland states, simply because that is where most people live. And here's an example: Middle East and North Africa. That region comprises 22 countries and now close to 400 million inhabitants. Accessible fresh water in that part of the world has fallen by about 2/3 over the last 40 years alone. Per capita availability of fresh water in the region is now about 1/10 of the world average. And by 2050, current projections show that it's going to fall by about another 50%. Now, parts of the, this is going to have a particular impact because so much of that part of the world is already classified as arid, semi-arid, dry. And so it's already on the borderline as far as water availability is concerned. And the region around the Persian Gulf is particularly vulnerable. It's, if we go anywhere close to the high-end scenario, much of this region is really going to become non-viable for human existence. So there's going to have to be a very substantial migration of people out of these areas. Where should we put them? Any ideas? If we get even a 1 meter rise in sea level, Bangladesh is going to lose at least 15% of its land area. Maybe that's another 25, 30 million people. Any ideas where we can put those? We're going to have some really profound challenges. And the world has not yet had to cope with the patterns of forced migration on that scale. So as we have to, if we go into this future world, we will have to start to think about how do we manage the progressive abandonment of a number of tropical and subtropical regions in particular and migrate towards the poles. I think most people would agree that this is something we should avoid if we possibly can. And yet we don't seem to be taking the threat seriously enough to be making the kinds of changes that we would need. But the impact just on this one small part of the world, Middle East, obviously has huge implications for world's availability of energy. And this is already a part of the world which has got some very deep and apparently irreconcilable conflicts. So if people have to start migrating across national borders, it's hard to see how well that we cope with the ensuing social pressures. And this is really just part of a larger picture of a world in which environmental factors are increasingly going to be impacting on our social and economic systems. A fairly recent report from the US National Intelligence Council pointed out that the world demand for food, for water and energy are all going up at the same time. By the time we get to 2030, we're going to need about 35% more food, 40% more water, and 50% more energy. And again, there are going to be some huge challenges as to where we're going to get these resources from. One of the, I think, most critical issues is going to be water shortages. The UN estimates that by the time we get to 2030, something like half the population of the planet will be living in water-stressed areas. And we're going to have to either get much better at how we manage flows of fresh water, or we're going to have to get much better at desalinating, or we're going to have to do something, but we're going to have to find that water. And a number of strategic assessments from both the US and UK and other countries have talked about the way that climate change and water shortages will act as threat multipliers, where you already have a situation of acute social stress, political conflict, etc., and then you have climate change, you have falling agricultural yields, you have water shortages, you have patterns of forced migration, and you do not have robust institutions, you do not have strong governments. The potential for social disintegration becomes extremely high. So what this means in terms of what we should be looking at now is we have to find ways to become much more efficient with how we use energy and water, and we have to go beyond looking for 5–10% improvements. We have to look for really quite drastic improvements. And we have to really be thinking about what is sometimes called closed-loop economies. How can we build economic structures where we have a very high level of efficiency in recapturing and reusing energy, materials that we now regard as waste? How do we extract the nutrients, the metals, etc., from our waste flows and recycle them back into our economic systems? How do we minimize wastage of water? How do we look to improve energy efficiency, possibly by an order of magnitude, right across our economy? We have to think of ways that we can develop low-carbon energy supplies. It means we have to look at things like energy storage. Energy storage is one of these issues that we always forget about. We look for new energy sources. Of course, one of the huge limiting factors or huge issues with renewable energy is that it tends to be intermittent, which means that you have to think about how can we can efficiently store energy in order to bridge between an intermittent supply and demand that unfortunately peaks at other times. So we have to look at things like next generation batteries, smart grids to balance between supply and demand, as well as, of course, looking at a whole raft of renewable energy technologies. But a very fundamental part of it is we have to find ways to live more efficiently, to run economic systems more efficiently. A lot of the emphasis really here has to be on urban living, simply because we are already more than half of humanity lives in cities. In another couple of decades, it'll probably be 2/3 of humanity lives in cities. And in cities, you actually have the concentration of people to make it possible to do have much more efficient transport systems, energy systems, waste recovery systems, etc. So really a lot of this boils down to, can we rethink how cities are organized and how they're managed and how they operate. Now the other problem, do you remember I started off by saying we've got more than one problem? Well, this itself is quite a large problem, but we've got another problem, and that is the very high cost of energy. Now this is specifically for us in the islands. These are the average retail tariffs this is the cost of electricity. And I'm sorry, it was about 5 years ago that I did this, so the numbers are about 5 years out of date. But what I found then was that if you looked at the energy costs in Latin America and the Caribbean, and you looked at the top 10 in terms of being the most expensive, 5 of the top 10 are in the Caribbean. The only 2 exceptions to the high energy costs of the Caribbean, we've got 1 or 2 oil producers in this region, and they obviously have low electricity costs because of the way that they actually effectively subsidize their electricity costs. But most of the rest of us in the islands have got expensive energy. And just as a comparator, that's where the United States comes in. Again, this number is probably out of date, but the average for the US was about 14 cents per kilowatt hour. And we've got countries in this region where the cost is about 50 cents per kilowatt hour. Now, how are you going to develop a competitive economy when your energy costs are 3-4 times higher? Because energy costs make your imports more expensive, your transport more expensive, your manufacturing more expensive, your services more expensive. It has a pervasive effect right through the economy. That cost is added on at every stage. And it's very, very hard to compete unless you can find ways to significantly reduce your energy cost. As the IDB pointed out, there is an inseparable linkage between the fiscal crisis confronting the Caribbean region and the reality of paying some of the world's highest per capita energy costs. Now, you'd think that with this combination of pressures, we would have done something about it by now. And yet, strangely, we're only really now just starting to grapple seriously with trying to find solutions to these problems. Problem 1 threatens our survival. Problem 2 fundamentally undermines our ability to develop competitive economies. Is this not important enough to be trying to solve these problems? Well, apparently it wasn't, because it's only been relatively recently that we've really started to get serious about trying to solve these problems. Now, the strange thing about this, the really strange thing about this, is that we're not short of solutions. In fact, if anything, we've got so many solutions, it's hard to know which one to do first. There's a number of very interesting and exciting new energy technologies in development. For example, and I just pulled a couple, seabed turbines. We tend to think of turbines as being for run-of-river. We've got small rivers, but there are very deep currents below the surface of the ocean, funneling between the islands, huge quantities of energy, and they run all the time. And some countries have got expertise now in putting a turbine down on the seabed, and it generates a lot of power constantly. It's cutting edge. It's not something I'd necessarily recommend tomorrow, but that's a very exciting next generation technology. Biofuels, we still think in terms of getting, converting sugarcane into ethanol. Well, that's really a first generation technology. We've got at least 3 more generations of technology already in development. Next generation is probably cellulosic ethanol, but generation beyond that is looking at things like genetically modified cyanobacteria, which can be tweaked to become more efficient in the production of long-chain hydrocarbons, which we can then refine into synthetic gasoline. So there are new technologies in development now, which potentially could solve the energy problem for much of the world. Solid-state, highly efficient solid-state solar cells. If you actually do just a little bit of looking around, you can see not one, but a new generation of energy technologies, which are not necessarily on the market yet, which are still in the R&D pipeline, but which may eventually have a really transformative effect. But these are very complex decisions. Which one would you bet on? Which one would you invest in? There are a number of variables to take into account. Economic factors. What is the capital cost? What is the likely fuel cost? What is the operating cost? Are there distortions in the market, which of course there are, like subsidies for fossil fuels, that have the effect of making your competing technology look uneconomic, even when in fact it's highly competitive? Or is it in fact, if we're subsidizing wind turbines, if we're subsidizing solar cells, which other countries do, can they actually compete in the marketplace? So we have to strip out the effect of market distorting subsidies and tariffs to get an idea of what is actually genuinely able to compete. Then you have to look at things like institutional structures. Who owns the grid? If the grid owner also owns a lot of legacy power plant, they may offer you very low tariffs because they don't want to have to shut down they want to write off their own power plants. And this can have a very discouraging effect in terms of getting people to invest in new energy technologies. Closeness to market, because if you're looking at energies in the R&D pipeline, you have to say, look, is this 2 years away? Is it 5 years away? Is it 20 years away? You have to make it an investment decision based on how close you think this is to actually being ready. So the dilemma for any government now is you look at all of these potential solutions, and the solution that would work best for us might well be in development, but it's an emerging technology. And no government wants to take the risk of betting on a technology which is not ready yet, and government wants to take the risk of committing to an energy strategy which could turn out to be an economic disaster. And there's quite a history of governments betting on the wrong energy policy. I have seen oil-burning power plants which were built and never turned on, never utilized, or nuclear power plants that got built and mothballed before they ever generated a single watt of power. Because people made the decision at a time when they could make certain assumptions about fuel costs. These stations take a long time to build. By the time they're built, the fuel cost mix has changed, and your plant is now economic, and you are living with a very expensive mistake for decades. So governments tend to be quite risk-averse when it comes to deciding which energy technology is the right one. And no government can take the risk of the lights going out because we don't have enough power. So, in fact, the sensible solution, the rational solution, is what's called a no-regrets strategy. Is there anything that we could do that would work under almost all possible future scenarios? And in fact, there is. The most sensible, rational, low-risk solution is actually to bet on energy efficiency, because that is the only thing you can do that works under pretty much all future scenarios. It doesn't matter where the energy comes from. If you're using it very efficiently, you've got both a price and an economic advantage baked in. So it actually makes much more sense for any government now to be investing heavily in energy efficiency rather than to be worrying about new energy sources, including renewable energy sources. And in a situation which we are in now, where our standards of energy efficiency and energy productivity are lamentably low, we are far below world average in terms of our general standards of energy efficiency. But because we're coming from such a low point, there are actually many more opportunities to improve energy efficiency in our economies in a highly cost-effective manner. And this is, even if, as is quite possible, energy costs actually go down in future, they fluctuate a great deal. Let's say that the US, for example, floods a lot of cheap gas coming out of the so out of the shale industry in future. This, again, energy efficiency still works. Whether energy is expensive or energy is cheap, energy efficiency is one of the very few strategies that actually works under all possible futures. And here's a very clear example. Look at the built environment. Buildings account for something like a third of world energy use, because we live in buildings, we work in buildings, we keep them warm. In cold climates, we keep them cool. In hot climates, they have to be lit, we need hot water, all of that. So buildings, in their construction, in their use, are a huge part of what we actually need energy for. About 10-20% of the energy is actually simply in the construction, but most of it, 80-90%, is in the operating of a building, in its cooling, heating, lighting, ventilation, appliances, and so on. So the really critical thing is to find ways to make buildings much, much more energy efficient in their operation. Make them easier and cheaper to keep hot or cool, and keep illumination levels up and keep them ventilated. And what a number of countries have realized is that we're not confined simply to looking for little marginal improvements here and there. With a bit of redesign, we can actually go to not just zero energy buildings, which is actually buildings that have a net zero energy demand, but even energy plus buildings, buildings that generate more power than they consume. Now, of course, if we can do this, then you have this very exciting possibility. You can actually start shutting down power stations and using your cities to generate the power that you need. So let me show you a couple of examples. Inside the building, oh, sorry, did I upset JPS there? All right. But don't worry, there is still a role. There's big money to be made in managing the grid, okay? You just shut down the bit of the business that's costing you money right now. So you're looking at things like the most advanced LEDs or organic light-emitting diodes for lighting, absorbent wall coatings to control humidity instead of having to use AC and dehumidifiers, efficient appliances. You know, for something like 30 or 40 years now, we've known how to make a refrigerator which actually runs on about 10% of the energy cost simply by insulating it better. And solar-powered air conditioning units. It's extraordinary that so many of the solutions are available, and we're just not seeing a commensurate rate of uptake into the market. If we could wave a magic wand and upgrade all the buildings in the world, even to the current basic energy efficient standards, we could actually reduce world energy demand by 20-25%. If we could make every building zero energy, we could take out maybe even as much as 30-40% of world energy demand. These are really substantial gains. And here's an example. This one is there, it's working now. This is in Seattle. And by good design and insulation, they've reduced the energy used by this building to about a quarter of a comparable building of the same size, in the same city, in the same climate. And then you see this big roof up here. That's your solar array. And that solar array is actually generating as much as the building needs. Now, of course, and this is where JPS can feel a bit happier, there are times when the people in the building are using more power than they're getting from the panels. And there's times when they're getting more power from the panels than they're actually using in the building. Now, you really don't want to have to use batteries to back up your power, because batteries are very expensive. What you really want is a grid. But you want a reversible meter. So you want there to be times when you need more power than your roof is giving you, when you're buying from the grid. And there's times when you're generating more power than you're consuming, when you want to be selling to the grid. So you really need a smart grid with a network operator who is both buying and selling, and balancing out supply and demand across tens of thousands of buildings across entire cities and entire countries. This has been running since 2008. This is in Freiburg in Germany. These are well-designed houses. They've got solar panels and hot water systems on their roofs. They're all connected to the grid, but they do not have any electricity storage because they basically don't need it. Every house that you see here, every housing unit here, is a net exporter of power. Every house here is actually exporting about twice as much power as they're consuming. Now, I know I've asked this question before in similar meetings, but how many people here enjoy paying their light bill? All those who look forward to paying their light bill, please show. I see JPS hands going up there. Okay. How many... Well, let me ask a slightly different question. How many people here would like to get a check from JPS every month? How many people here? All right. Okay. Most people would prefer the experience of getting a check from JPS, right? Than having to write a check to JPS. Okay. Well, the thing is, the people in these houses, and these have been running since 2008, that is their experience. They actually get a check from the power company because they're net exporters of power. So given that we've got a pretty good solar regime, why haven't we gone down this road? This is really quite puzzling. Given that we actually know what many of these solutions are, why haven't we been a bit more agile or a bit more aggressive in developing these solutions? This is one in development. This is in Colorado. By good design, they'll reduce energy demand by 80%, and then solar and geothermal will allow them to become net exporters. This is a lovely idea. This is going to be, if it goes through, one of the biggest rooftop farm in the world. This is in Brooklyn. And this is opens the way to how cities can actually become centers of agriculture and can start producing power. At the moment, we take our sewage and we run it out into, what do we do with it? Leach it into the sea, typically. But why don't we recapture the nutrients and cycle it back into urban agricultural systems so that cities can actually start producing their own food? This is another design. This is a prototype for a tower in Singapore with energy and water recovery systems built into the design of the tower. So you can actually start to think in terms of cities now that actually are self-sufficient in terms of food and water. This is really quite a radical rethink of how cities should be. So the key points are really these, that we already know how to do this, that with better planning and design, we can reduce the energy demand from buildings to make them net zero or even energy plus. Then, of course, ideally, we probably need something like a smart grid system to balance out the supply and demand. And by building in things like integrated water management, rainwater harvesting, grey water systems, etc., we can actually not only reduce total consumption of water, but we can then support things like urban agricultural systems so that we can actually think how to design cities that supply their own energy, their own food, and their own water. And this would actually take us a very far way towards solving our problems with climate change. So what's not to like about this? We actually solve multiple problems at the same time. Of course, we talk about the need for vision a lot. I've never known I don't know any other people in the world who talk about vision so much. You know, we have Vision 2030 and Trinidad has Vision 2020, is it, or something? So we have all these visions. Well, the thing is, the vision is the easy part. The hard part is working out how do we get there from here. That's the really hard part. Because quite often you come to the conclusion, well, we shouldn't start from here. We should start from somewhere better. Unfortunately, we don't have that choice. We can only start from where we are with all of the problems that we've got. And so the really tricky part is figuring out how do we get from where we are with all of our issues and all of our problems to where we actually want to be. So this is what we have to think about. How do we deliver the right mix? What's the combination of policies or regulations or incentives or sanctions? What is the mix that will, without causing too much pain, start to shift the economy in the direction of better outcomes, like, for example, more efficient designs and structures? What is the role, what is the role for research and development? Where is it needed? Who is best placed to do it? Is it the universities? Is it the private sector? Should the government be supporting research? And if so, what kind? Or should we be leaving this more to the market? That's another critical decision. Of course, if there's going to be uptake, it can only be the private sector. It's the contractors and it's the developers who really have to be implementing this. But then they don't work in a vacuum. They work in a context of planning controls and building regulations and so forth. So what should the planning controls say? What should the building regulations say? It's probably the case that you need to have some way of actually rating the performance of buildings, because you can't actually tell by looking at the outside how efficient it is. So we need to have some kind of like star scheme or rating scheme so that you can tell before you buy. You get an idea of whether this is a highly efficient or a very inefficient building. So we have to put that in place. There are some performance rating systems around. We have to look at those and say, well, is one of these more appropriate for us, or do we need to develop our own? Now, the minister who was actually here not very long ago, we got him to the ceremonial launch of our construction project up at the university, where he was photographed leaning elegantly on a shovel. In fact, we all were. And he said, we need to make all new buildings in Jamaica net zero energy by 2050, which was great to get that said. But of course, we have to think, is that enough? Is that going to be soon enough? Is there anything that we could do that could encourage a faster transition? Because if you recall what I said at the beginning about the issues with climate change, we actually may not have the luxury of that kind of timescale. So we have to think in terms of, could we do anything to accelerate this? And of course, we have to build prototypes, which is exactly what we're doing now up at the university. Ladies and gentlemen, thank you very much indeed for your time and attention.
Short question. I know that we're here to talk about the built environment and buildings, but part of the built environment includes planning. And I'm just really asking whether anything similar to this is being done with regard to transport policy, because when you see that transport and roads, and I don't think that even includes the building of roads, but just vehicles on the road, are using 28% of imported fuel compared to 33% in buildings, it's obviously a big issue that is not really talked about much. We've kind of given in to using motor cars only, and very little public transport.
One of the strange things about Jamaica is that we have got one of the world's highest percentages of kilometre of road per head of population. We're in about the world's top 3. Now, if you look at the quality of the road, we are actually got some of the, we're in the world's bottom 3. So it seems that our transport system is being very badly affected by, of course, a legacy of patronage and corruption, and pushing road building and maintenance contracts out to people who didn't actually know how to fix roads. So a lot of our roads are in very poor condition, and this actually has a major impact, obviously, on the cost of maintaining motor vehicles. Then we've got a public transport sector, and we have its market has been eroded by a lot of unlicensed taxis, which are running around and causing mayhem. Part of the reason why we've got so many problems with unlicensed taxis is that I was quite surprised recently. I did a review for the government and discovered that about half of traffic tickets, traffic violations, go unpaid. And what happens is, instead of paying the traffic fine, people simply go for the court appearance, but they don't make the court appearance. And then the clerk of the court has to write out a summons, and they ignore that too. And this can go on, you can go on pretty much indefinitely. As a result, I realized the government is actually foregoing about $500 million a year in income. That's the money in uncollected traffic fines. The other consequence is that we've got people running around on our roads with not a few outstanding traffic tickets. I looked at the worst 50 offenders in Jamaica, and they have got on average 650 outstanding traffic tickets each. The top four, in the sort of the gold, medal winners prize, had over 1,000, outstanding traffic tickets. And the gold medal winner had, I think, 1,350 outstanding traffic violations. So this is a major contributing factor to the fact that we actually kill about 400 people on our roads every year, because we don't have any mechanism to get the insanely dangerous drivers off the roads. So, and then, of course, because we do not have a public transport system that's perceived to be safe, that's a major deterrent. Most studies indicate that the perceived safety of the public transport system is the single biggest factor in deciding whether or not people use it. You know, it's going to be if people think that there's a high risk when they take public transport, then of course people will quite rationally prefer to use their cars instead. Then we have cultural issues about the fact that cars are seen as status things, as opposed to simply a means to get from A to B. The ways our cities have developed, where you live in Portmore or a Spanish town, and then you have to drive in and drive back, which is really kind of in many cases unnecessary. I realized when there's bad traffic, it can take me 90 minutes to drive across the city to get to my office to sit in front of a laptop. I realized actually I could stay at home and sit in front of a laptop and give myself 3 hours back every day, which has actually made me much more productive. And there's plenty of people in office jobs who basically all they need is a corporate intranet, and they could work from home. We could take that amount of traffic off the roads. If you look at other countries, like, for example, when I was in New York recently, you see all the school buses involved in moving children to and from. One of the biggest contributors to traffic volume is school pick-up and drop-off. And that we have better solutions for that too. But I think perhaps the biggest issue, and this is not obviously imminent, but there are countries which are now pushing very hard to a world of driverless vehicles. And by probably something like 2030, 2040, they will be mainstream. And then we'll have the whole idea of a vehicle being something that you get into will, I think, start to look increasingly archaic and obsolete. Now, what I think very few people have realized is what this means in terms of how many vehicles we need. The average vehicle in the United States is in use for about 5% of the time. The rest of the time, it's sitting parked outside your house or outside your office. When we move to something like the Uber model, where you push a button and within 90 seconds you have an automated vehicle pick you up, take you wherever you want, you have no maintenance costs at all, you have no depreciation issues, no capital outlay, and the vehicle is then in use pretty much all the time, you get an incredible efficiency gain. You can, in the United States, which is obviously a very big industrial economy, could get all of the people transport and freight transport it needs now if we move to driverless vehicles for about 20% of the vehicles that are currently in the US fleet. In other words, you can take 80% of the vehicles off the roads once you have this one small technological shift. So the potential for doing much better through proper planning, through telecommuting, through better organization, through making public transport safe, by actually applying traffic tickets, and then thinking about how cities are going to reshape as we move into a world where we need far fewer vehicles. If we could actually start to think about these things now, we could come up with a really good transport policy for this country. Thank you.